Hello and good afternoon to all of you, respected sir. In our bachelors, we know what is the oxidation is. The oxidation meaning of oxidation is addition of oxygen and removal of hydrogen, or we says loss of electron. So today, my name is Panchadarshan. My name is Panchadarshan, and today we are talking about oxidation of aldehyde to carboxylic acid. This topic is our in our unit 4 free radical reaction. Oxidation of aldehyde to carboxylic acid has been carried out with many oxidizing agents, the most popular of which is acidic, basic or neutral solution of permanganate, chromic acid, silver oxide, bromine, benzoic solution, failing solution. The mechanism of aldehyde oxidation may be free radical or ionic. Both of the mechanisms make place together. Free radical reaction Free radical reaction oxidation, we take H2CrO4 as oxidizing agent. In the free radical mechanism, the aldehydic hydrogen is abstract to give a acyclic radical which obtain OH from the oxidizing agent. For example, first we take aldehyde and react with chromic acid. It gives acid radical and plus Cr in plus 5 oxidation state. Now, acyclic radical react with the chromic acid and gives carboxylic acid and Cr at a plus 5 oxidation state. Ionic oxidation with alkaline permanganate solution. The mechanism is similar with KMnO for also for alkaline permanganate. The ionic mechanism is as follows. For example, first we take aldehyde and react with OH minus. The OH is attacked on the carbon because carbon has a partial positive charge and it gives R bond, C bond, O bond, H bond, OH. Now, the negative charge of O is attacked on the single bond and give us double bond, and the hydrogen is abstract and give us HMnO4 permagnetic acid, and we as a product we get carboxylic acid. Next, ionic oxidation with the neutral and acidic permanganate. For a neutral and acidic permanganate, the ionic mechanism has been proposed. First, we take aldehyde and react with the permagnetic acid HMnO4. It Now we also know the carbon has partial positive charge and oxygen has a partial negative charge, and bond of Mn bond OH is a weak bond. So the OH is attacked on the carbon and MnO3 minus attacked on oxygen. So we get RC bond OH bond H bond O bond MnO3. It gives us carboxylic acid, and the MnO3 minus abstract from the reaction, and the hydrogen is react with B minus and give us BH. Ionic oxidation with H2CrO4 chromic acid. Similar with H2CrO4, the ionic mechanism is as follows. First we take aldehyde, react with a chromic acid as a product we know R bond, C bond, H bond, OH bond, O bond, CrO3H. We know that the carbon has partial positive charge, oxygen has partial negative charge. The OH is attacked on the carbon, and CrO3H attacked on the oxygen. The electron of O bond CrO3H, the bond of O and CrO3H is breaked and give us HCrO3 minus Cr at a plus 6 oxidation state, plus 4 oxidation state, and the B minus the B minus react with hydrogen who abstract from the reaction, and give us BH. The last, atmospheric oxidation. Aldehyde are also Aldehyde are also oxidized to a carboxylic acid by atmospheric oxygen. The direct oxidation product in this case gives us peroxy acid RCO3H, which disproportionate with another aldehyde, another molecule of aldehyde, to give the two molecule of acid. So first we take aldehyde, react with R dash radical and give us R dash H, because C bond H bond is very weak. The H abstract from the solution and give us acyclic radical. Acyclic radical react with atmospheric oxygen and we get R bond C bond O double bond O. The, the O has a charge electron. Now the radical react with carboxylic acid, react with aldehyde and give us free radical and peroxy acid. There is the structure of peroxy acid, and the peroxy acid react with the molecule of aldehyde and give us two molecule of carboxylic acid. That's it. Thank you for your attention.